How does a spark plug receive such high voltage if a car battery only provides 12 volts? To function properly, a spark plug needs at least tens of thousands of volts. However, a car battery only supplies 12 volts. So how does the spark plug get such high voltage? This is thanks to two essential components in the ignition system: the breaker, also known as the contact breaker, and the ignition coil. Let's start with the breaker. It's connected to the engine's camshaft through a cam follower. The breaker has two contacts. One is movable, connected to a return spring, and the other is fixed. On the left side, there is a capacitor, whose function we'll explain shortly. On the opposite side of the movable contact, there's a cam that touches the breaker arm. This cam is not perfectly round. As the engine's camshaft rotates, it causes the cam on the breaker to rotate as well, which periodically opens and closes the breaker contacts. Now let's look at the ignition coil. Inside, it consists of a primary winding and a secondary winding, the latter wound around a metal core. One terminal of the battery is connected to the ignition key, which then connects to one end of the primary winding. The other end of the primary winding connects to the breaker, forming the primary circuit. The secondary winding is connected directly to the spark plug, forming the secondary circuit, and the entire circuit is controlled by the breaker we mentioned earlier. Now, suppose the breaker is closed. The battery current flows through the primary winding, creating a magnetic field around it. When the breaker opens, the current drops suddenly, causing the magnetic field to collapse. This collapse generates a self-induced voltage of around 30 volts in the primary winding. At the same time, the changing magnetic flux through the core induces a high voltage in the secondary winding. If the primary winding has 30 turns and the secondary winding has 20,000 turns, and the self-induced voltage in the primary is 30 volts, then since voltage is proportional to the number of turns, the secondary voltage reaches around 20,000 volts. This high voltage is then delivered through a wire to the spark plug. The spark plug has a central electrode, which often contains a resistor to prevent damage from excessive current. Because the voltage is extremely high and could pose a risk to the occupants, the central electrode is surrounded by an aluminum oxide ceramic insulator which withstands high temperatures and voltages while providing excellent insulation. On the bottom half of the insulator, there's a side electrode made of iron, threaded so the spark plug can be securely installed at the top of the engine cylinder. There is a small air gap between the central positive and side negative electrodes. When high voltage is applied, the air in this gap is quickly ionized, resulting in dielectric breakdown and the formation of an electric spark. This spark ignites the air-fuel mixture inside the engine cylinder, pushing the piston and powering the engine. But there's one issue. The breaker opens and closes constantly with every engine cycle. This rapid switching causes electrical arcing between the contacts, which over time damages their surfaces. To solve this, the capacitor in the breaker absorbs part of the energy by storing electrical charge, which helps suppress the spark and protect the contacts. However, modern vehicles no longer use traditional breakers. Instead, they rely on electronic control units, ECUs,